So complex numbers or imaginary numbers. We have difficulties with real numbers now. Here come imaginary numbers. This is something that we need to do, put out a formula in the next chapter, which is chapter 8. Anytime we have square root of a negative number, you will get an error if you put it in the calculator, because you can't take the square root of a negative number. That's what you've been told all these years. But in reality, square root of -1 is the letter I. So someone says, do you have an iPhone? You simply say, I have a complex phone. Square root of -1 would equal I. I is an imaginary number. In general, the general form of a complex number is A plus I times B. A is what we call the real part. B is the imaginary part. The imaginary part is the part of a complex number which makes it complex. If this wasn't there, then it's not a complex number. It's just a real number. But if it's there, then we have a complex number. For example, three plus 2i is a complex number, yes? How about -7i? Is it complex? What is A and what is B?
There is no A.
There is no A, which means A is
Positive.
0. So A is 0, B is -7, right? If you have difficulty seeing this, I can write this as 0 plus I times -7. So A is 0, B is -7. We have a complex number. Is that a complex number? 7/5 minus 2/5i. It is. A is 7/5. What is B? Is it -2/5 or +2/5? -2/5. Good. Is the number 2 a complex number? No. Number 2 is not a complex. Complex conjugate. So if you have a complex number A plus IB, I times B, B times A, they mean one and the same. It's like a partner in crime. So A minus IB will be its conjugate. Vice versa, if you look at A minus IB, A plus IB will be its conjugate. So once again, we have to know this because in chapter 8, when you do the quadratic formula, sometimes you would have a solution or solutions that are simply conjugates of each other. So if A plus IB is a complex number, its conjugate is A minus IB. Let's see, what is the conjugate of 3 plus 2i? 3 minus 2i. What is the conjugate of negative 7i? 7i. What is the conjugate of 7 over 5 minus 2 over 5i? 7 over 5 plus 2 over 5i. Good. Suppose we want to add two complex numbers, 3 plus 2i and 7 minus 2i. All we have to do is add the real parts together, then add the imaginary parts together. So 3 plus 7 plus I, add the imaginary parts, 2 here, minus 2 there. So 10 plus I multiplied by 0. Is the answer a complex number? It is.
But it's 0.
But it's 0. Now, in a complex way, get it? Every number is a complex number, if you think about it. Its imaginary part is just imaginary. It's just not there. Let's see. I want you to give that one a try. So we add the real part to the real part, imaginary part to the imaginary part. So 14 plus 11 plus I, imaginary part of the first number is 1, the second one is 7. $25 plus 8i. Now, why did we talk about the complex conjugate? When you divide complex numbers, it's not as easy as dividing real numbers. Suppose I want to divide 1 minus I by 1 plus I. The way we divide is by multiplying and dividing by the conjugate of the denominator. So what is the conjugate of the denominator? 1 minus I. Important side note. If you take a complex number, multiply by its conjugate, the answer is always the real part squared plus the imaginary part squared. Always. Complex number, multiply its conjugate, you will get a squared plus b squared. What is another way of getting this? You FOIL, but this is a simple identity, just like a plus b times a minus b equals a squared minus b squared. A relevant one in the complex area is a plus ib times a minus ib is b squared plus b squared. 1, 1. So 1 squared, using the side note. Numerator though, I have 1 minus I times 1 minus I. Good. In order to get an answer in the standard form a plus ib, I now have to FOIL. So 1 minus I times 1 minus I, minus times minus plus, and then I have I squared divided by 2.
Was it 2
Okay.
again? Okay.
Real part is 1, imaginary part is 1. You're multiplying complex number by its conjugate, real part square plus imaginary part square. 1 squared plus 1 squared. So numerator, I have 1 minus 2i. Here is another interesting aspect of I in and of itself. We know square root of -1 is I. What is I squared? 1 or -1? You square on both sides, you'll have -1. Good. All you have to do is know these two, and you can come up with any value. I raised 94, I raised 78, whatever. So I squared here is -1 divided by 2. What happens to the 1 and the -1? Cancel. Have -2i divided by 2. The 2's will get cancelled. The answer is -i. So the conjugate of the denominator is 3 plus 4i. Numerator would simply be 3 multiplied by 3 plus 4i. That part's easy. I'm just distributing 3 in. Denominator, a is 3, b is 4. Doesn't matter which one you pick. Multiplying a complex number with its conjugate. So the denominator is simply a squared plus b squared. Distribute 3 times 3, 9, 3 times 4, 12i, divided by 3 squared, 9, 4 squared, 16, 16 plus 9, 25. You can leave that as is, or the common denominator is 25, so I can write it as 9 over 25 plus I times 12 over 25. I can split it because the common denominator is 25.